Welcome back, everybody. Today's deep dive is going to be pretty mind-blowing, even for me, and I've been prepping for this.
Oh, yeah.
Yeah. It's all about RWKV-CLIP,
Okay.
and this is all about AI that can, understand the connections between images and text.
Yeah.
Really wild stuff. Super efficient, too.
It really is. And it solves a huge problem in AI.
What's that?
Like how to make these models really good at what they do,
Mhm.
powerful,
Mm-hmm.
but also make them efficient.
Yeah.
The old models, like those transformers, they just eat up so much power.
Oh, yeah. Like they need a whole data center to run.
Exactly. So RWKV-CLIP is changing things up.
How so?
Well, it pulls from different ideas like transformers,
Okay.
which, are amazing at parallel processing.
So they handle, tons of information at the same time.
Right. But it also takes ideas from RNNs, which are super efficient with memory.
So it's like a hybrid model.
Exactly. Best of both worlds.
That's awesome. But even the name RWKV-CLIP sounds kind of scary.
Yeah, it does sound a bit technical.
What does RWKV even stand for?
It's receptance weighted key value.
Oh, wow.
But the main thing to know is it's this new kind of neural network,
Okay.
all about being fast and not using a ton of power.
Gotcha. So even though the name is complex, the idea is all about keeping things simple and streamlined.
You got it.
Yeah.
And that's important because these models need so much data.
Yeah, we're talking massive data sets of images and text. Oh,
Tons of it. And usually scraped from the internet, which can be a bit messy.
oh, totally. Think like mislabeled pictures, bad grammar in the descriptions, all kinds of problems.
Yeah, exactly. But that's where RWKV-CLIP really stands out.
So,
It uses this really smart framework to make descriptions for images, even if the original data is kind of bad.
so it's not just about being fast, but also making sure the information is right.
You got it. It's not just looking at the captions that are already there, which can be wrong.
So where does it get the info?
Multiple places, actually.
Oh, really? Like what?
Well, it starts with those web captions, but then it also uses captions made by other AI models. Those are usually perfect grammar-wise, but sometimes they miss the real-world details.
Interesting. So it's like having a grammar expert and a fact checker working together.
That's a good way to put it. But there's even more.
What else?
It uses these things called detection tags.
What are those?
They're like labels that pick out the specific objects and details in the image.
So it doesn't just look at the whole caption, it breaks down each part of the picture too.
Exactly. And then all this stuff, the web captions, the AI captions, the tags, it all gets fed into this powerful language model.
And what does that do?
Think of it like a master weaver taking all these threads of information and weaving them together to make this super detailed tapestry.
Wow. So by doing all that, RWKV-CLIP can create a way more accurate representation of what's going on in the image and the text.
Exactly. And that leads to some really cool results. Like RWKV-CLIP is amazing at what we call zero-shot learning.
Zero-shot learning, what's that?
It means it can do tasks without any specific training for those tasks.
Wait, really? That sounds like magic.
It's pretty close. Like imagine you search for images, but you only use words. Like a cat wearing a tiny hat riding a skateboard.
That's specific.
That's zero-shot image text retrieval. And RWKV-CLIP is great at it.
Wow. So it's like it just gets the connection between words and pictures.
Yep. Even for stuff it's never seen before. Because during training, it learned how to align these representations of images and text.
So it built like a map where similar images and text are close together.
You got it.
That's wild. This is also fascinating, but can we get to some real-world examples?
Sure. So the researchers tested RWKV-CLIP on a bunch of benchmarks.
Okay.
For example, they used data sets like Flick30K and MSOCO for image text retrieval tasks.
Those are like thousands of images and captions, right?
Yeah, and RWKV-CLIP was consistently beating out the other models.
And so not only is it more efficient, but it's also more accurate.
Exactly. And it's not just image text retrieval, it was also amazing at zero-shot classification.
Remind me what that is again.
Identifying objects in an image even if it's never seen those objects before.
So like a super image recognition system.
Pretty much. They tested it on things like Food 101 and even ImageNet, which is huge.
And it did well.
It aced it, especially on data sets with lots of different types of objects.
That's incredible. RWKV-CLIP sounds like a major step forward.
It really is. And it opens up so many possibilities for applications that need both power and efficiency.
Like what?
Well, think smarter image search engines or AI assistants that can understand what they're seeing.
Okay, now I got to ask, what about the downsides? Every AI model has some right.
Of course. One thing is that it still depends on those existing caption and tagging models being accurate.
So if those mess up, it messes up the whole thing.
Yeah, it's a bit of a chain reaction.
Gotcha. And anything else.
Well, there's also the issue of scaling it up. Training on truly massive datasets takes a lot of power, even with all of RWKV's efficiency.
So there's still work to do.
Definitely.
Yep.
But the potential is huge. Just imagine what we could...
It's really amazing to think about. I'm really curious about the RWKV architecture itself now.
Yeah, that's where all the magic really happens.
What are the key things that make it so efficient and powerful?
That's a great question, and one that we'll dive into right after this. All right, so we're diving into the heart of RWKV-CLIP, the RWKV architecture itself.
Yeah, I'm ready to get technical.
Okay. Well, it all boils down to how it handles attention.
The attention.
Yeah, it's how these models decide what parts of the data are important, whether it's words or pieces of an image.
So it's like the model's way of focusing on the right stuff.
Exactly. Now, transformers, those use self-attention.
Good.
Meaning they look at everything at once, all the words, all the image parts. It's good for spotting complex relationships, but it takes a lot of computing power.
Kind of like trying to read a whole book at the same time.
Perfect analogy. You might get the main idea, but it's a lot of work and you'll miss some details.
Right.
Now, RNNs, they work differently. They go through things one by one, word by word, or image part by image part. They have a memory of what they've seen, but it can be slow.
So it's like reading a book one page at a time.
Yeah. You get a deeper understanding, but it takes longer.
Makes sense.
And this is where RWKV gets really clever.
How so?
It does this cool thing with time decay.
Time decay.
Basically, as the model sees new information, the importance of older stuff fades away.
So it remembers what it needs to, but doesn't get bogged down with every little thing.
Exactly. It can capture long-range dependencies like RNNs, but much more efficiently.
Cool. So where do those receptance weights fit in?
Ah, that's the secret sauce.
The billet.
The model actually learns to give different weights to different parts of the input,
Okay.
based on how relevant they are to the task.
So it's not just going in order, it's learning to prioritize.
Exactly. And that's how it gets the parallel processing of transformers with the memory efficiency of RNNs.
That's wild. But the key value part is still a bit confusing.
Okay, good point. Imagine a huge library. Each book is a piece of information.
All right, I'm picturing it.
Now, each book has a label on its spine that's the key.
So the key helps find the right information.
Right. But the key doesn't tell you what's inside the book.
That's where the value comes in.
Exactly. The value is the actual content of that information.
So the key is like the title and the value is the story in the book.
You got it. RWKV uses these keys and values to calculate those attention weights we talked about.
So it's always checking the keys and values to see what's important.
Precisely. And this is where it gets really powerful. It can process tons of information quickly without sacrificing accuracy.
That's pretty amazing. But how does all this make RWKV-CLIP understand images and text?
Ah, good question. It uses a two-tower architecture.
2 towers?
Yep, one for images, one for text.
Okay.
And here's the key. Both towers use the RWKV architecture.
So they're both using those keys and values and attention weight.
Exactly. And during training, they learn to align images and descriptions, bringing similar ones closer together.
Closer together.
Yeah, it creates this high-dimensional space where distances represent how similar things are.
High-dimensional space.
It's like a map, but instead of being flat, it has tons of dimensions.
Oh, wow.
And things that are similar in meaning are close together, even if they look different.
It's like a map of meaning.
Exactly. And that's how RWKV-CLIP can do those zero-shot learning tasks.
It's figured out the connections between images and text, even for things it's never seen before.
Right. It learned to navigate this complex space of meaning.
Wow, this is all really impressive. So it's the RWKV architecture and that text generation framework working together.
Exactly. It's a powerful combination. And it shows what we can do when we mix different approaches in AI.
It's not just about building bigger models, it's about finding smart ways to solve problems.
Exactly. And it's just the beginning. Who knows what we'll be able to do in the future with this kind of technology.
Yeah, the possibilities are endless. But I think we're ready to move on to the bigger picture now.
The implications of RWKV-CLIP for the future of AI.
Exactly. It's time to see where this all might be leading us. Okay, so we've gone deep into RWKV-CLIP now.
We have. From the big picture down to the nitty-gritty.
My brain is definitely full.
It's a lot to take in.
But it's amazing stuff.
Yeah.
One thing that really stands out to me is how RWKV-CLIP mixes different ideas.
Right. It's like it's taking the best parts of transformers and RNNs and adding its own twist.
Yeah. and it's outperforming those models that just stick to one approach.
It's a great example of how combining ideas can lead to something really innovative.
And I bet we'll see a lot more of that in AI.
Definitely. The problems are getting more complex. We need all the tools we can get.
Makes sense. It also shows how important data quality is.
Oh, absolutely. It's not just about having a ton of data. It needs to be good data.
Yeah, like we said, garbage in, garbage out.
Exactly. But what's cool is that RWKV-CLIP actually uses AI to make the data better.
Oh, yeah. And that leads to more reliable models.
It's like a positive feedback loop, better data, better models.
And that has huge implications for everything.
For sure. Everything from science to our daily lives.
Imagine if all AI models were trained on perfect data.
Right. They'd be more accurate,
Yeah.
fairer, less biased.
That's the goal.
It is. As AI becomes more powerful, we have to make sure it's trustworthy.
Absolutely. And RWKV-CLP is a good step in that direction.
I think so.
Another thing that impressed me is how it balances power and efficiency.
Yeah, for a while it seemed like AI was all about bigger and bigger models.
Right. Like whoever had the biggest model wins.
Exactly. But RWKV-CLP shows that you can be smart and efficient.
And still get amazing results. It's not just about brute force.
Right. Especially as we start using AI on smaller devices, efficiency is key.
Like phones and sensors and things like that.
Exactly. It's about making AI accessible to everyone.
And that brings us to the most exciting part, the applications.
Yeah. Where can we use this technology?
I mean, we've seen it's great for image search and object recognition.
Right. But it could go so much further.
Like what if we had AI assistants that could really understand what they see?
That would be incredible. It could help people with visual impairments.
Or anyone who needs to analyze visual information quickly.
And think about science. Researchers could use it to analyze huge amounts of images and videos.
And find patterns that humans would miss.
The possibilities are mind-boggling.
It could change almost every field, healthcare, manufacturing, education.
It's a little scary, but mostly exciting.
It really is. AI is going to change the world in a big way.
It already is. But I think RWKV-CLIP shows we're on the right track.
Towards AI that's not just powerful, but also responsible and helpful.
That's the goal.
Well, this has been an awesome deep dive. I've learned so much.
It's been a pleasure talking about this.
Thanks for guiding us through it all. And to everyone listening, we hope you enjoyed it. Until next time, keep exploring, keep learning, and keep wondering about the future of AI.